Okay, if you want to use something other than Microsoft to do your Excel work or your word processing work for this class, LibreOffice is an option. If you go to LibreOffice.org, you can download LibreOffice for free. It can work on Mac, it can work on Windows. So if you just go to LibreOffice.org and then I click download, that's how I got to this screen. I have opened a LibreOffice Calc or spreadsheet and also a text document. So we will try to use that to do the kind of things we need to do for Lab 2. I'm selecting this first set of data and I want to put a graph in here. There's an insert chart icon over here. There's lots of little icons. If you can't figure out what they are, there's also a menu up here, so you can insert a chart this way. Either thing calls up this chart wizard, so if I had clicked the icon, this would appear as well. We want an XY scatter plot just with dots, not with any of these connecting lines, just XY scatter with the dots. And then we'll click next. We have the data range selected. I did not select the labels, so I won't check either of these boxes. And this is just showing what the data range is. Later on, we'll add a second line. We'll come back to this screen, but I think for now it's looking pretty good. We can put our chart title in here. The x-axis is going to be the concentration, and you always want to put the units as well. Otherwise we won't know what that's trying to tell us. And then the y-axis is the density, again with the units. So the concentration is our independent variable and the density is our dependent variable. So we're making things of certain concentrations, we're controlling that, and then the density is what we're measuring. We're trying to see what happens. So whenever you're seeing what happens, that goes on the y-axis. And then the title of the graph should always be the y versus whatever the x is, because we're seeing what happens to the density when we change the concentration. I like lines horizontal and vertical, so I want both in my grid. So we have the data, we have the chart title, we have the concentration and the density. When you list them in the spreadsheet, whatever you want to be along the x-axis, you should list on the left, and then the y should be on the right, and then it will plot it that way. If you wanted to edit any of these chart elements, there's a little menu up here. So let's say that the legend, we didn't really want something on the side here. We don't like how it looks. We can select that. We can delete it. You could insert, like if I wanted to put the legend back, I could insert the legend. You could insert some titles. We're missing the x-axis title. So if you forgot to put something when you were going through that chart wizard, you can add it later. So if you don't like the spacing of this axis, if you don't like the fact that these dots are all really squished together, you can hardly tell that the line slopes upward, then you can adjust the spacing on the axis. You can either, here I've selected the y-axis, you can either go to a title and format the y-axis and call up this menu, or there's also a little icon here, y-axis, that calls up this menu. So we have the scale on automatic. I'm going to maybe make it start at 0.6. Let's try that. We could even start at 0.8. Let's do that. So now you can really tell that there's a slope. You have your data spread out. If you ever have a chart and all of your data is clumped together so that you can't see what it's doing, you should spread out the axis a little bit. All right, the next thing we have to do is put a trend line. We're going to have the spreadsheet calculate what's the best fit line to these data points. So we don't want to connect them and have a little zigzag. We want a straight line that goes through the points the best that it can. And right now we have the chart area selected. And so if we insert trend line is not working, we need to have the data selected. So you can either select it over here by putting data series, or you can click on one of the data points that will select this data series. Now you can insert a trend line. Let's move this over here so we can see. And we're going to be using linear. Most of the time there is a lab later on that uses a different kind, but for most labs we're going to have a linear fit line. And we want to show the equation and also show the r squared value. So let's click OK for now. Okay. So we have the equation. It's in the format y, which is f of x, the function of x. So this is our y, equals mx. So this m in front of the x is the slope, plus b. The number afterwards that's not multiplied by x is the intercept of the line. So that shows where it would hit the y-axis. If it kept going, it would hit it at about 0.87. That looks right. And also it's going up. It's a positive slope in the upward direction. The r squared gives a measurement of the fit. Anything above 0.95 is considered a good fit. If the dots were closer to the line, that would be an even higher number. The closer you get to 1, the better these dots fall on the line. So one other thing that we need to be able to do is to extend the line, because we have a question on our part A where we need to see where the line is for data points that are not shown. So I'm going to try to go backwards, maybe about, I don't know, 7. Okay, now we're off the chart, so let's go ahead and look at the axis. I don't know why it didn't call up when I chose this. I had to click this icon. I need to make the x-axis go a little bit further so that I can see where the line is going. Okay. Let me select the data again so that I can see the trend line. Okay. So now we have the trend line going backwards far enough that we'll be able to see things that hit it. Let's say like if it were 0.9, we'd want to see where 0.9 hit the trend line. We couldn't do that before. Now that the trend line is extended, we can do that. I want to try to paste this chart into a word processing document. It's a little bit hard to select the right object though. So try clicking a box outside of the chart so that we don't have the menu up here that says chart area, and then click on that. Then we'll go ahead and copy it. You can paste it just to make sure that you have the entire thing. Okay. And then you can make a text document and paste it in there. I think for questions 5A and 6A, it's easier to draw the line once it's already been pasted into a text document. You can insert a shape and choose a line. So if we wanted to know what density we had for a concentration of 30 mass percent, we can draw a line up to our trend line. We can make it thicker if we want. The line width, we can make it a little bit thicker. We can change the color over here. Make it orange. Okay. And then once we've followed this up to our trend line, let's see if we can insert another line here. We can then follow it over to the density. So according to this line, it looks like a concentration of 30 gives a density between 1.1 and 1.2, maybe 1.13, something like that. Let's make it a little thicker too. There we go. So what has happened here is that we've gone from having just 6 data points to having a line, which is an infinite number of data points. And so this line is expressing the relationship between the concentration and the density. And so we're trying to find the point on the line that corresponds to 30% concentration and then figure out what density that would mean. So what density is related to that concentration. So for your lab, you're not doing density and concentration, but you are finding something on the x-axis, following it up to your trend line and going across to the y-axis. There's another question about finding something on the y-axis and going over and following it to your x-axis. So let's say that we wanted to know for a density of 0.95 what the concentration percent would be. Let's go ahead and do that visually with a line. So for a density of 0.95, we follow it over to our trend line. And then when we drop that down to the concentration, the mass percent, it looks like the percent is maybe about 9%, a little bit less than 10. So either 8 or 9% concentration would give a density of 0.95. So visually, you can use the graph to determine that. Another part of the questions, 5b and 6b, is for you to actually use the equation in order to calculate that as well. One thing I have noticed about the equation while I was just doing that was that this one originally in the spreadsheet had really kind of too many digits. And then when we went to the text, it chopped it off maybe a little bit too much. Now it kind of has too few digits. And I noticed how to fix that a little bit, I think. All right, I'm going to get rid of this equation. So the first thing I noticed is that if you want to, instead of f of x, you could just call it y, if it makes it easier for you to see that y equals mx plus b equation. So now you have y instead of f of x. And then I double-clicked on the equation and hit numbers. And then if you choose number, you can choose to maybe keep it to 5 decimal places. That's probably plenty. So that's a little bit more reasonable, I think. Now I'm going to choose a box over here, choose this again, and copy and paste it. And now it has that reasonable number of digits. It didn't go chopping it off anymore. So you have at least a few digits to work with when you do the calculations for 5A and 6, or 5B and 6B. You don't want to have just, one significant digit here for the slope. Have at least a couple. For part B, we're going to have to be able to plot another set of data on the same graph. We want to plot this second set of data as a separate line, not as part of this first line. So first we have to get back into the chart. We don't have that chart drop down over here. So I'm going to go ahead and double click this. So with this chart selected on the drop-down menu, let's try Format Data Ranges. And select Data Series. So this data series is called column B, probably because these density values are in column B. All right, so I'm going to say that this is substance A because this is the concentration of substance A. And then I want another data series for concentration of substance B. So I'll add one. Substance B. For the X values, I want these ones. And I'll click that little box so that I can select the range. And then for the Y values, I'll click this box and select this range. Okay. All right, there we go. So I'll click the Y-axis. Okay, that just makes it look a little bit more on the chart there. Now I'm going to select this data range because we want a trend line for that one as well. Show the equation, show the R squared value. I think I would like this to be Y. Put this a little lower, and then I'll double click that so that I can define this number to have 5 decimal places as well. So there we have a chart with 2 different lines on them. Let's take a look at what we're doing for part C. In addition to making a graph, we also want to calculate the average and the standard deviation of a set of measurements. So this is a little bit different, the data from your data for Lab 2, but we were saying that we have a set of data points that we took with one scale and a set of data points we took with another scale. For your lab, you are measuring Lab 1 and Lab 2. There's some volumes that are being measured. All right, so I've put the data over a little bit and labeled average and standard deviation. So I'm going to select this box. I want to put the average of all those data points inside the box. So first I'll click equals, and then I'll start typing the word average, and then we can select that. Or we can also use this menu up here to select it. So I want the average. All right, let's try that again. So you put an equal sign in there, which recognizes it as a formula, and then you can choose different settings from that drop-down menu over there. So this is going to take the average. You can select which boxes you're going to take the average of, or you can type it either here or here. We want to use boxes B19 to B28. And then if you press return, it will calculate the average. For standard deviation, I have the equal sign. I'm choosing standard deviation, STDEV, and those same boxes, B19 to B28. Don't go down and include B29 because that has your average. We just want the 10 measurements. And this is our standard deviation. I'm going to select these two boxes and copy them and put them over here. So if you select this box over here is giving the average not of B19 to B28, but C19 to C28. So these ones over here. So it's doing the same thing, but with the values that are right above that box. So that was just a little shortcut. Also, this one has the standard deviation of those measurements. The averages are pretty close to each other. The standard deviations you can see for scale 2 has a smaller standard deviation. So that means that these values are grouped a little bit more closely. And that's hard to tell just by looking at the list. The standard deviation gives you some idea of that. But if you look at this data in a graphical visual representation, you'll be able to see that as well. But we don't want to plot this as the x and this as the y. We don't want to plot this and this as our point. We just want all of these points to be above the number 1 because they were taken with scale 1, and all of these points to be above scale 2. So I'm going to take the points, not the average, just the points, and put them over here. These are going to be our y values. And these are all the points that were taken with scale 1. And then these points, again, not the average, just the points. These points were all taken with scale 2. So this is the type of data that we want to graph, actually. I'll select that and insert a chart. And I would like the XY scatter plot with no lines on it. We're not going to put any lines this time, just the XY scatter. The only other thing I would do here is I just like to have both dimensions in the grid, but it's your preference. The chart that it comes up with, to me, seems to have pretty large data points. They're all kind of smushed together. I found that if you select the data point and double click it and choose line, you can change the size of the symbol that you are using. Maybe make a round dot over there. So now you can see them a little bit better. You could probably change the color that way too if you want. So if we click on here and get this chart area selected again, then we should really have some titles. So what we have on the y-axis, remember the title is y versus x. So again, the x-axis is the scale, the y-axis is the mass measurement. So really, once we have the titles, we're done. We're not having a trend line. Again, these sets of data are not related to each other. They're not connected to each other. The reason why we have a graph is just to show us that the scale number 1 data is a lot more spread out than the scale 2 data. That's just more clumped together. All these measurements are pretty precise, and we could tell that from the standard deviation as well. Another thing we can tell by looking at it graphically is taking a look at the data points that might be outliers. If we hover over it, then we can see that the value is 65.66, so that value seems to be a little bit further from all the rest. So you might want to look at that one as possibly being an outlier. The lab asks you to take a look and see which data points might be outside of the rest of them. Here's one that's 63.44. So it's easier to see that visually on this graph than just by looking at the list trying to figure out which number is furthest from all the others. So that's another helpful thing about having a graph for this data.